Alright, welcome back. Let's take a look at the functions we added in the math extensions folder. These really are array functions, except for this one, which is an actual math function. I'm going to pause it on each function for a few seconds so you can copy it down. We have another function called add here. It is a generic, it's using a generic type. Basically, it does do a null check, so we do not have to actually initialize our array until we use it. Of course, this is horrible on the memory, but really our models are not going to be big enough to worry about that in runtime. The add range simply adds a range to the end of the array. So first of all, we check if the array is null. If it's not, we're going to copy that array into our results, and then we're going to add whatever we're trying to add, the range we're trying to add. And lastly, we're doing a group addition. We're adding to the entire array whatever value we pass in. This is an integer only, it's not generic. So if our array is all 0 and we pass in 1, it'll be all 1. This will use we'll use this for the face indexes. So that is that. Okay, so let's jump over to the HA part class. We are going to add some properties to this. This is a marker class. It's simply going to be something that our main class looks for and can get through the mono behavior by type. And I will explain these in 1 second. Okay, so we have a root. I don't use that, but it's everywhere, so I'm going to keep it. We have a selected. This is for the editor. We want to be able to move this object around the screen. We're going to show it in the screen with a marker, with a spear button in the editor, and that way we can actually drag it around to where we want the bone, the bone's anchor to be. The bone's anchor is important for the actual avatar. The bone name and the human name. I don't understand Unity why they have two names on this. It seems redundant, and that seems to be a big breaking point for most people. You can set them to the exact same thing as long as you set them to what Unity is expecting in the human avatar. So, as for instance, left upper arm, left hand. So they can be set to the same thing, but you can also have a nicer name if you want, or they have a nicer name for it. The source of this is where we're getting our vertices, our normals, our UVs, our tangents. For this tutorial, let me show you the finished project. Here is our feller. I think he's a feller. He looks like a feller to me. He's just a blocky guy. He has eyeballs. They do work. Let's see here. Grab an animation. So he does work. He is linked well. In this case, all of our parts are separate. You don't have to do that. We'll talk about bone weights in a little bit, but you don't have to. They can be from one single mesh. Of course, that would ruin the point of merging different mesh parts together. So let's get rid of him. And originally I called this CS0. Why? I have no idea. I cannot remember. I know the 0 was because I thought I was going to have to take multiple passes to figure this out, and that didn't happen. So move you back over there. Okay, so that's for our part. Now let's go over to our parts, and we need, this is a convenience function, and it is basically going to mark all of our children as active, because we're going to mark them as inactive each time we're messing with this. So we need to pass true into the get components children, so we get inactive children of this component. I'm not doing any error checking here. Very simple, very straightforward. Okay, let's jump over to HA Parts Editor. We may use Part Editor, I don't know. That might be an unnecessary file in the end. Okay, so I have some code that I like to stick at the top of almost all files I'm working on. This basically kills all of those unused variable warning messages that Unity will pop out and Microsoft will pop out. Why? Because we're in development mode and we really don't need them. We know we haven't used them because we just typed it in. We're going to be using the Unity editor, of course, in an editor in the Unity engine. Editor. Now we have to tell this what it is editing. You're editing the HA parts. If you notice, the start and the update are now grayed out. That's because we don't need them. So we need to set that variable to a value, and we'll do it every time this becomes active. And now we can use that variable. So that will simply mark all of our parts as active as a convenience. No other point to that. All right, let's jump over to the HA file. This is where all the magic happens. I have some redundant code in here, but right now we're going to go ahead and use it. Some redundant and some unused code. Show gizmos. We want to show our spear handles in the front in the editor when this is clicked. Edit mode. Am I even using that anymore? Yes, I am. Okay. Bones. Give a little bit more correct name over here. We have to use a horrible dictionary. But making one custom really isn't worth it. Animator. We need to provide an animator so we can put the avatar on it. Okay. Let's get our avatar, aviator. So you can tell Unity really overworked this stuff when you're working with it. Human length, human description, human length. What is Mississippi colon? And this is just generally going to pump out the bone name and the human name of each bone. Very simple. Now we need another part called fetch parts. mBones is equal to get components in children, our HA part. And we do want to get inactive ones. What? No. It said bones, not bone names. IntelliSense has gotten so stupid. Okay. Now we have another convenience function here. It's a little bit long. Well, no, this one we're actually going to use. We're going to configure our actual skeleton. So we'll call this public void list bones. Bone names is equal to a new dictionary. mBone names chest is equal to biped 001 spine 2. mBone names head. Tell you what I'm going to do. I'm going to copy these over here from the current code, and I'm going to freeze the screen across the two parts just so you can get a look at it. You can pause and type all that in. Don't need the double. And then scroll down and get the second part. Just too much code to type out here. Basically, we're typing in. I would positively do a typo sooner or later in this. Okay. I will try to get these posted down in the comment section or in the description section. I don't really want to create an off-site account where everyone has to go out to it to get this information. So let's continue here. Next of all, we are going to create a convenience function called required bones, and all this does is going to tell us what bones are required. This is just for debugging. You'll never use it in your game, hopefully. Very simple function. Required bone. We'll just call that from the editor. Alright, let's go back up to the top. Leave it on there for a couple seconds. And now let's go back up to the top and create another animator. We'll make this one private. And we'll use it down here. Actually, yeah, we'll use it in just 1 second. Create the avatar. List the bones. Horrible name in hindsight. Get the component. The animator. Human description. I gotta create that function first. It's not a bad function, but human description. arm stretch really doesn't affect the way our model is set up so much, but we'll still put it in there. Did it again, didn't I? And now I've got to jump down and create another function to finish this function. Let's go ahead and put return description so that error line, that squiggly line, goes away. Create the skeleton. That would not be a good name, Microsoft. Game object, avatar, root. List the skeleton bones. The skeleton. I think the biggest problem with the build avatar function is it's very abstract. So you really don't understand it until it's finished. And then it makes total sense. And really most things in .NET are not like that. You understand them as you're going. So here I am getting all the transforms for our avatar, which we will define shortly. Skeleton bone, bone. And bones and bones and bones. Okay. Name is equal to avatar transform name. Good enough. Name. What's wrong with you? Yeah, local scale. Skeleton dot add bone. And we are working mainly with arrays, so we are going to convert that to an array. Now we need one more function to finish our create human description function. It's another version of get required bones. But instead of printing them, we are going to return them. Human bone. No. Human trait dot bone name. If human trait required bone human bone equal to new bone, bone name is equal to bone name I. Human name is equal to bone name I, because I don't care. use default values? Yeah, go ahead. Now we're going to use our add function to add it to the array. One of the biggest problems with a extension that changes a array size like these is that you have to make it equal to the add function. So you can't just say add like a list. You have to actually have to return the value, the new result list in most cases. But if you're modifying the values like with addition down here, in all actual fact, in this case, I'm modifying the original list and I'm returning it. So if I'm not changing the size of the array, its reference place is still in the same place. It's still arrays of reference and it's still the same spot. So I'm just changing the values in the reference, and that it allows. But if I'm changing the array, I can't simply set list equal to results at the end and not return it. Just some general information. You decide to use those functions again. And this is for debugging that we will not use in the section, but go ahead and put it in there. Okay, now we can finish our create human description function. Our skeleton is equal to create skeleton avatar root. Our human is equal to get required bones. Now I'll hover over these for a few seconds so you can pause and copy anything you missed. And now let's continue. First function we're going to create is a preview function. This is where we're actually going to create our mesh. We're not going to create a skin mesh here with our preview function. We're going to create a mesh filter. And it's just going to show us what our final product is going to look like. So since we're going to use, if you couldn't tell when you looked, when I showed you our model, we're going to use Unity primitives. We're going to go ahead and just use Unity normals and tangents. We don't have to actually recalculate them because they're already good. We're going to steal those from the meshes, the different primitives that we use to create our model. When you use this, you have to remember, if you click preview, you need to remember to get rid of preview when you go ahead and create the skin mesh, which we'll do next. And right now I'm just checking if any of these things are already on our game object. And if they're not, I'm going to go ahead and add them. Unity recommends that when you're manipulating a mesh in the editor, you use the shared material and shared mesh objects or properties off of the mesh filter and the mesh renderer. In your actual game, you probably should use the actual mesh and actual material. Okay, so we have a max face index. That is where we're going to use our addition function. Generally, while we're looping through all of these separate meshes, we have got to increment our face index of the next mesh that we import, because it's no longer going to be, we're combining them together, so they're no longer going to be the same. They're going to be equal to the max of the last face index. Or is it the max plus 1? Yes, max plus 1. So for the int of n is equal to n is less than m bones dot, no, bones dot length plus n. If m bones n dot part is not equal to null, so if we forgot to set this part, we're still going to create the bone, but there's going to be no mesh there. There'll be no vertices assigned to it. So we need to do a matrix for, because we're going to be dragging those primitives all over the place to put them in the right spot. So we have to manipulate the vertices to where we've moved them. And we'll talk about that again when we go to do our actual model. Mesh filter, source mesh filter is equal to this bone dot part get component mesh filter. If the source mesh filter is not null, hey, we're good. Hey, held the shift key down too long there. For the int of I is equal to 0, I is less than source mesh filter dot shared mesh dot vertices. Now I could use vertices count, but I don't want to. And our vertices is equal to our vertices add. I'm at 4 dot multiply. So here's where we're translating it. Now, as far as our normals go, they're much easier. We don't have to translate them. In fact, if you did, you mess everything up. And just take whatever normals are on the primitive, whether it's a sphere, cube, whatever. Our tangents, same thing. UVs, same thing. FIS, shared mesh dot triangles clone array. We don't have that function yet. Cruddy. All right, let me pause here. Now, all right, I had to do a quick pause there to go get this function. We need a clone array function for our integers. And why do we need a clone array for our integers? Integer is a value type. It's not a reference type. But the array itself is a reference type. We need this to be separate. We don't need to add to every we don't need to add to our actual mesh. So we're going to take its triangles and put it in another array, which is a copy of our array, but it's a different reference. Literally, if we didn't do this, we would be adding to the primitive, and we would be messing up our base primitive objects, and that would be bad. And now okay, hold on. Face indexes is equal to add range. So now we're going to add them to our overall face indexes. Max fi is equal to fi psi max. We got to bring in link. I know link is horrible, but it's also great. If you want to go out and do a custom function to do a max of an integer, I don't think you can actually do it better than link, unless you do it in like C++ and do a marshalling thing, which I've done before, just for fun, but it's not really, it's nothing that you can notice. And we're going to turn off that object because we don't want to see the original one. Collapse, come on. And now we're going to say our vertices is equal to our vertices. Our mesh.normals is equal to our normals. Our mesh.uv is equal to our UVs. Our mesh.tangents is equal to our tangents. Our mesh.triangles is equal to our face indexes. And our mf.sharedMesh is equal to our mesh. Okay, we have one more big function to go. We'll do that one in another video next. And then we got to go set up our front end. And that is the most boring and tedious process of this whole process, is setting up our QB spherical primitive guy model. There's actually a lot there, and it gets really tedious. So I'll see you in the next video.